Hi, this is David Bird. I'm going to do a presentation on controlled parallel processing in Dell booming integrations. I have written some past blogs on this. This is a major one that I think y'all should review, and I have a few listed at the end. Really, the use case is getting data through a web service. If you do it in serial, it can be just an unacceptable challenge. The example here is they have 100,000 transactions, 90% get through in 3 seconds, and 10% take an average of 45 seconds. This was actually into a health application product whose only way to get data into the product is to use a web service. So if you did all the math, that would take 200 hours or 8.3 days. For the use case, the customer actually had to get 834 enrollment data into the system in 24 hours and print enrollment cards within that 24-hour period. So we had to reduce the 800 or the 8.3 days down to less than a couple hours. The way to do this is in parallel. So how do we want to do this in Dell Boomi? Well, first, I want to keep it simple. I want shared reusable code among queues, and I really don't want to add any extra licensing cost. So I'm going to jump from here for a moment to show you the actual data that I came up with. So I'm just doing this for testing simulation. I wanted about 1,000 rows, so I got 50, I think, of the most famous quotes, or 100, and then I also got a bunch of different movies. So we have 1,000 rows there. Actually, 1,049. Anyway, so I want to take this, actually store this up in a table, and that table would be here. Alright, so this is a Postgres database. The table I'm looking at is this data that I just showed you from a spreadsheet is now here in this. And okay, so from here I wanted to take this data and present it in a view as either how I want to access it via parallel and how I want to access it serially. So I have these two tables, or these two views. That show me the ID and the queue I'm assigning it to, which is 1 through 10, the message, a reformatted version of that message out, and a timestamp, which I'm not using in this case. And then the serial version looks like this. Same data, but everything now is only Q1. So we have two views presenting the data slightly differently, but with the same rows, or the same number of rows, the same columns within those, and should access the data from reading it in the same way. So now I want to go back to the presentation. Here's the data sample I mentioned. Here's the two views, the way I created them. I built a test process to read the parallel source. I assigned the queue that I want to read. I got it to work through end to end. So this is how I built the test process, which This is the test process. It reads from the database, reformats the data a little bit, splits it, makes sure we can handle it, loads it to the database table, and finishes. Very simple. But at first I needed now to build a process that would feed the queue numbers in to this sub-process that I just showed you. And that sub-process is working individually for a particular queue. So doing that, I needed to first build a view that would return me a list of queues that have data in them. So this view returns, these are the queue numbers, and this is the number of records to process. I did a left join on the output table so that if it's already been processed, those records wouldn't be processed again, so you can actually control what's been already loaded and reload. Anyway, so we go take this. Alright, so this is reading those queues in. The last step's fairly important. We'll get to that in a minute. This step is setting the queue number, but ultimately we're taking the data in, we're passing one of the records, which is either the queue number and its count, to the sub-process. Sub-process is a data pass-through process, so it picks up that document and continues to go. That's about it for this screen. The sub-process, though, the most important thing here is that you uncheck this box, make sure it's not checked, so that as soon as it submits the sub-process, it goes and gets the next record and submits them. So at one time you could have 10 of these sub-processes running, because right now the queues are set for a max of 10. Now the sub-process. We're in here. This is set to data pass-through, so we get the first document. This set properties actually looks at the profile of that document, grabs the queue number, and from there uses that queue property, number property that's defined, to determine what queue to run, and it just loads that and grabs it and loads it to the other database, and it's done. The serial process, if you look, looks almost identical. It just reads from that serial view out, pre-assigning any queue or anything, just reads from the serial view and writes the output table. Here you can see them side by side. Before going on, I'm writing to a second table in a Postgres database to simulate calling a web service. Since the database is actually in the cloud, this is not a far stretch. Yes, the actions could be completely done using a completely done SQL, but I'm trying to simulate was processed to a web service, and I want to show this in parallel. Anyway, that's what I was attempting to process. The results, I was hoping to see at least a 65% improvement since I was simulating the queues. I knew there would be some slight overhead from Boomi, but I wasn't sure how much there would be until we could actually get a measurement. And here's the measurements. So the top 10 rows are the number of records we processed, the amount of time. Really, the last thing is the total message process time. So the first message in, at that point, to the last message processed out, took 4.6 seconds, up to 5.2 on a few. The total process time took 5.3 seconds, where when we did the serial test, all the records got through in about 47 seconds. The improvement here is 89%, which exceeds my mark. And based on this result, I got a reduction of essentially 90% improvement on the throughput of the data. If you'd like to see my other blogs, I have them here and here. Thank you very much, and I hope you'd enjoyed this.